To solve for the derivative of g of x equals the quantity x plus 5 to the power of x, I first started by changing g of x to y to make it easier to solve for the derivative. Then I took the natural log of both sides to get ln of y equals ln of x plus 5 to the x, which we can also rewrite as x times ln of x plus 5. To solve for the derivative of this equation, I split the right half of our equation into two different functions, f of x, which equals x, and h of x, which equals the natural log of the quantity x plus 5. This will make it easier to use the product rule so we can determine the derivative of this function. Using implicit differentiation, I changed the left side of the equation to be y prime times 1 over y, since 1 over y is the derivative of the natural log of y. Then, using the product rule and the two functions I defined in the step above, I was able to find the derivative of the right side of the function, which was the natural log of the quantity x plus 5 plus x over x plus 5. I found this by multiplying the derivative of f of x, which is 1, by h of x, which is ln of x plus 5, and then adding that to the derivative of h of x, which is 1 over x plus 5, by f of x, which is just x, to get our second term in the right side of the equation, which is x over x plus 5. To get y prime on the left side of the equation by itself, I multiplied both sides by y. Since we know that y equals the quantity x plus 5 to the power of x from the beginning of our problem, we can multiply the right side of the equation by y to get our final answer, which is y prime, or g prime of x, equals the natural log of x plus 5 plus x over x plus 5, all times the quantity x plus 5 to the power of x. For our second problem, we have to determine if the following statement is true or false. The integral of x to the 7th plus 7 to the x dx equals x to the 8th over 8 plus 7 to the x plus 1 over x plus 1 plus c. I found it easiest to split our original integral into two separate integrals added together, so I got the integral of x to the 7th dx plus the integral of 7 to the x dx. The first integral was relatively easy to solve, and I got that the integral of x to the 7th dx equals x to the 8th over 8 plus c. To solve the second integral, I used the exponential rule, saying that a to the x dx equals a to the x over ln of a. Therefore, the integral of 7 to the x dx equals 7 to the x over ln of 7 plus c. I then added the solutions to these two integrals together to get x to the 8th over 8 plus 7 to the x over ln of 7 plus c. This does not equal x to the 8th over 8 plus 7 to the x plus 1 over x plus 1 plus c, so the original statement in our problem is false.